Okay, so this is 17. It says, given a test to a group of students, the grades and genders are summarized below. Find the probability the student was not a male that got a C. So I'm going to write it like this: male C. Okay. I want to know the not of that. So the complement. So I'm going to first figure out what this is. What's the probability of being a male who got a C? Well, 20 men earned a C out of 64. So I'm going to say 20 out of 64 is the number of men who got a C. But if I want the complement, I'm going to do 1 minus that. 1 minus 20 over 64 is going to be 44 over 64. So if they want a decimal, we can do that. We have 44 divided by 64. Whoops. 0.6875. Or I'm sure they would probably take the fraction, 44 over 64. Okay, 21 says if one pedestrian death is randomly selected, find the probability the pedestrian was not intoxicated or the driver was not intoxicated. So we're saying probability of ped not intoxicated or driver not intoxicated. So we're going to use the or formula. This is going to be the probability of the first thing, probability of ped not, plus the probability of driver not, minus the probability of both. So the probability of pedestrians not intoxicated is going to be these two added together. 686 over 985 plus the probability the driver was not intoxicated. That's going to be these two. That's 857 over 985 minus the one I counted twice, which is the 611. 611 over 985. So I'll put that in the calculator and we'll see what we get. 686 divided by 985 plus 857 divided by 985 minus 611 divided by, divided by 985. Nope, nope, nope. I want the 611. There we go. I'll hit math. Enter to get a fraction. Whoops. What happened here? 686, 95, 857 divided by 985. Oh, that's what the problem is. So we'll delete that. Put the fraction at the end. 932 over 95. I guess they want a decimal. I don't know why I even did that. Okay. Nope, I don't want that. I don't want the fraction. 0.94619. 0.9 or 94.6%. So you probably were close. I don't know what mistake was made, but you had it. Okay, the last one says if two different pedestrian deaths are randomly selected, find the probability that they both involved drivers who were intoxicated. So it says, all right, they both involve intoxicated drivers. So probability of driver intox and driver intox. So what's the probability the first driver was intoxicated? So here's the drivers. So it's going to be 45 and 77, which is 122. Let's double check that. There we go, 122 over 976 times, we got what we wanted, so this is going to be 121 over 975. Divided by 976 times 121 divided by 975. 0.0155. As a percent, that would be 1.55%.